Okay, in today's lesson we will be using regression models to predict values using our graphing calculators. The first thing to do is to clear any numbers that are in your lists already. And here's a step-by-step way to do it, and also show you live how to do it on the graphing calculator. So let's take a look. So we go to Stat, Edit. As you can see, I have values entered for L2 and L3. So in order to clear, you actually have to highlight, arrow up, hit clear, and then down arrow. Do the same thing for L2. Clear, down arrow. Pretty simple. So here's a quick snapshot of various types of regressions. Here we have our linear regression, which you're used to. It's like the line of best fit, which you may have heard from Algebra 1. Here we have exponential regression, which if you remember, when x is 0, y is always equal to 1, because anything to the 0 power is 1. So it goes up like this. Your logarithmic regression is basically your reflection of the exponential regression over the line y equals x. And the power regression is the most often confused with the exponential regression, but to remember, the exponential regression goes through the point 0, 1, but the power regression does not, and the power regression only exists in quadrant 1. So let's take a look at this question here, which is pulled off of an old Regents exam. A population of a single-celled organism was grown in a petri dish over a period of 16 hours. So here's your x columns from 0 to 16 hours every 2 hours. The number of organisms at a given time is recorded in the table below. So here we have the number of organisms, and it's growing, as we can see. It looks like it's exponential, so we're going to determine the exponential regression equation model for these data, rounding all values to the nearest 10,000. Using this equation, predict the number of single-celled organisms to the nearest whole number at the end of the 18th hour. Okay, so this is really a two-part question, and this would be like a 4-point question on the Regents exam. You would get 2 points for answering this question, which is determining the equation, and you would get another 2 points for predicting how many organisms there will be after 18 hours. This is how we do it. You enter your numbers, just like this, 0 through 16, under the first list. Under the second list, you enter the other numbers, the y coordinates. Once you get that, you want to right-click over to Calc and go down and choose option 0, which is EXPRED. That stands for exponential regression. Once you're there, you want to choose, you want to hit exponential regression and then the name of the list that you chose. For me, I used L1, L2, so I type L1, comma, L2. Make sure you include the comma. Okay? This is what it gives us. Y equals A times B to the X, where A is this number and B is this number. I'm going to round to 10,000th place, which is 4 decimal places. You need to write down, in order to get full credit, you need to include y equals. If you don't have y equals, you'll lose a point. If you don't round correctly, you lose another point. So please include 4 decimal places when they say 10,000, and make sure you include the x here. You want to write the full equation in the correct format. Okay? Now, the second part of the question asks, to the nearest whole number, how many single-celled organisms are there after the 18th hour? So basically, you must show the substitution of 18 in for x. If you don't do that, then the graders of the Regents, they won't know how to give you full credit for this if all you do is you answer the question and put down the answer, right? They won't know how you got it. So you must show this plugging in step And then you do the work on the calculator, 27.2025 times 1.1509 to the 18th power. And the answer is 341 and some change over here. But since they asked for the nearest whole number, you would simply write down 341. And this is how you get the full 4 points on the Regents if this were a 4-point question. And most likely this would be a 4-point question. Now I wanted to quickly show you the various types of regressions. You have linear regression of the form ax plus b, quadratic regression, cubic, quartic. Linear regression again of the form a plus bx. They're honestly, number 4 and number 8 are interchangeable. Ln regression stands for logarithmic regression. That's probably the most confusing because remember ln is natural logarithm. And then of course we have the power regression. Okay, let's look at this one here. And I'm choosing this one because this is actually a 3-part question. So the accompanying table shows wind speed and the corresponding wind chill factor when the air temperature is 10 degrees Fahrenheit. Write the logarithmic regression equation for this set of data, rounding coefficients to the nearest 10,000. So again, 4 decimal places. Using this equation, find the wind chill factor to the nearest degree when the wind speed is 50 miles per hour. In other words, we want to predict what the wind chill, what it would feel like outside if the wind was blowing at us 50 miles an hour. Based on your equation, if the wind chill factor is 0, so 0 would fall between 0 and 5, what is the wind speed to the nearest mile per hour? So it's sort of the opposite. What would this be? Right? And they're giving us 50 miles per hour. What would it feel like? So we're kind of taking turns. Here's your x value, find y. Here's your y value, find x. But the first thing is first, we must plug these into our calculator and find the logarithmic regression. So, after doing so, you end up with this right here. Y equals 13.0134 minus 7.3135 ln x. Please include the ln x. So, when we plug in, right, we want to solve for what it feels like when the wind's blowing 50 miles an hour. So we simply replace our x with 50, plugging into the calculator. I'll show you how we do that. You literally just type it in, type in the expression. $13.0134 minus 7.3135 ln, and x is 50. Close the parentheses, enter, and we have negative 15.59, which they want it in the nearest degrees, so it's negative 16 degrees Fahrenheit. Okay. We're almost done. Finally, we want to make a prediction. Let's just write this in. It's negative 16 degrees Fahrenheit. Finally, sorry, yeah, that's right. We want to make a prediction. If it feels like it's 0 degrees, how fast do we think the wind is blowing? So, this means we must plug in 0 for y. And that's exactly what we've done over here. Okay? And basically we need to algebraically solve for x. So I'm going to add 7.3135 ln x to both sides of my equation so that everything is positive. I need to isolate ln x, so I'm going to divide by 7.3135. That cancels out this over here. 13.0134 divided by 7.3135 gives me 1.7794, and ln x is now isolated. Now, what is the inverse of ln? It is e. So we need to take e to the power of ln x, which we know since e and ln are inverses, that cancels out. X comes down. And e to the 1.7794, let's go ahead and use our calculator for this. Second ln, that's how we get e, 1.7794. And we end up with 5.9. And let's see, they wanted us to round to the nearest mile per hour. So our answer is 6 miles per hour. And that makes sense because 0 is very close to, it's closer to 1 than -5, and 6 is much closer to 5 than 12. And this also is a reasonable answer because at 50 miles an hour, which is the fastest speed, -16 is the coldest temperature here. So ladies and gentlemen, there is how to use regression models to make predictions for whatever the situation is, whether you're given the x, you solve for y, or whether you're given the y, you solve for x. Best of luck to you.